Hello everyone, today I want to share a simple model analysis with Abaqus. And as we can see here, it is a sphere shear and it's made of steel, and inside is empty, so it's just a shear part. In this analysis, we extracted uh, the first 21 mod frequency. Then let me show you how to create this model. And here the part is imported as MP file, so it's the orphan mesh as we can see. But if you want to create this shear part in Abaqus, it is very simple too. And first we need to know the dimension of this shear part. So let me measure it as so the diameter is about 6, and we can evolve it revolution and shear revolution. So the diameter is about 6, so the radius is 3, and I can input the center of the circle and the radius. So this is the sketch of this shear model. Then we need to delete the unnecessary length and make it a closed sketch. Oh, we don't need it enclosed. So just revolute 360 degrees. It can be a sphere shear. And then we need to mesh this part, and here we can first participate it as 8 parts. So I will use the datum planes to participate it. So I created the 3 datum planes and use them to participate this shear. Because it's shear, we need to use this button. So first we select this and click OK. Then we need to choose the 2 parts and select second plane, and then we need to create all the parts and the last plane. So it has divided into 8 parts. Then we can create the structural mesh, as you can see. So the element size is about 0.2. Maybe it's fine enough and fine than the one we created originally. So if we has created this part, we need to create a material and section property, and the material is steel. We need to input the density and elastic parameters. Density is about 7670, and the yes modular is 180 gigapascal. The pulsation is about 0.333. So here is the material. Then we create a shear property, and this property includes thickness of the shear, and the thickness is about 0. Let me check it, and 0.03, and we need to assign the section property to this part, and okay. Then we need to make it instance, and in this model we just suppress the first part. So then there is just the one we created here. In the step module, we need to create a frequency step, and in the step we input the angle values we need to extract, 24, 21, and the frequency shift, and then we click OK, and in the field output, the pre-selected variable is displacement. We just keep it as at default, and then we can go to the load module. Of course, there is no boundary condition for this free vibration analysis, so we just make the mesh and create a job for this module and submit it. Let's wait 4 seconds, and it will be completed in 1 minute. Okay, it is completed, and we can check the result. Let me see the frequency. About the first 6 frequency is about 0 Hertz, and for the other, for every frequency there is about 4 similar angle values, because this part is all symmetry about the center plane, so it can have the same deformation mode in symmetric direction. Now let me show you how the field deformed in every mode. So this is the first frequency, and it's the rigid motion. The second, 6, all the 6 modes are rigid motion, and the next one is elastic mode, so we can see the deformation mode for this sphere here. So this is the 7th mode, and the next one is the S mode, we can see it just deformed in another direction, and the deformation mode is always the same with the seventh. And also for the next, and we can see it's changed to another direction. So for 20th mode, and deformation is different from the before ones, and we can see here and the next 4 mode, it changed the direction, and for the next mode it changed to another direction. So we can get the frequency curve for this model. So this is the model number, and here is the frequency, and we can see here for the first 6 mod the frequency is about 0, and but for the next 4 it has a frequency, and the next 4 it has a similar frequency, and for the next 4 it has also the same frequency value. So the frequency has a relationship with the symmetry of the model and the material parameter, and it primarily is the elastic Young's modulus and density. So for a simple part, we can get the free vibration angle values of the structure we need to analyze. Um, Here is the all content of this tutorial. After this tutorial, we can get any part of the free vibration mode of structure we need to analyze. So if you are interested in Abaqus CAE, please subscribe my channel and learn more. Thank you for watching.